in my second thread example, second thread is implementing runnable interface, correct? Now, let me make second thread a child of a thread. So what is the difference? Runnable has an unimplemented method that a second thread must implement. If second thread becomes a child of thread, thread already has its own implementation of run. Now second thread, if he wants, he can take the run implementation of thread or can override his own. So let's save it as second thread 2, and we will go to change it to as a child of thread. We'll change him as a child of thread. Now we're going to make some other changes within the program, because a child of thread cannot call a thread object in its constructor. That's why it's complaining about, like, why would you want a thread in a thread? So now we're going to remove this, guys. Okay, so we're going to remove this. We're going to remove that. Okay. So this is what we're going to rather do. We're going to say, as soon as my constructor gets called, I want to call the constructor of my parent. This is what you learn in Java 1, that a child can call, okay, and then also you have to change your implements to extends. I forgot to do that, extends. That's why it was complaining. Okay. So I'm changing my call so that instead of me setting the name, I'm letting my parent constructor set the name for me. Then, instead of me having to say thread.start, I'll just say start, means call the start version in the parent. And then they'll automatically call the run. Whose run will be called? The one in the parent or one in the child? Now let me rephrase it. Who's calling the start? The parent or the child? Child. So whose run will be executed? Child's. So whoever calls start, if they have a local implementation of run, it will be their run they'll execute. If there's no local implementation of run, then the one in the parent will going to run. So we will going to leave the implementation of the run as it is in the child. We'll save the changes. So the only thing we changed is we changed the class from a child of runnable to a child of thread. As a result, it became a thread by itself, so it did not need to create a thread object. Now, let's go to run with multi-thread app and let's save it as run with multi-thread app 2. Now change this to second thread 2, 2, 2, and 2. Now you run it. And as you run it, you will notice that it runs exactly the same way as before. But now you can do something different, which I'm going to be doing next. Let's try to check the status of each thread to see if they're still alive or they're dead. So system.out.println is th1 alive. th1 is alive. So we're making a check. Is th2 alive? So th2 is alive. So let's make a check. I'll get rid of this th3. Now run it. And you will notice that right in the middle of the run, it just runs lines 10 and 11. Right? If you go back to your execution, you will notice thread 1 started. Thread 2 never started. Right before that, because CPU was free, he picked up on lines 10 and 11 and said, well, they're alive. So what I want to do is, I want lines 10 and 11 to only run when both threads are done. Okay, what I want to do is I want the lines 10 and 11 to only run when both threads are done. So for that purpose, I'm going to start a try catch block here. I want to try this, and of course I want to have a catch of interrupted exception E. And I'll say, you know what, TH1, even if you're done, you should wait for TH2 to join you. And TH2, even if you're done, you should wait for TH1 to join you. So I'm basically making them wait for each other. Now when you rerun this program, you will notice that the alive status only comes to live towards the end. Because until and unless they join each other, lines 14 and 15 will not run.